Welcome to the Mathematical Isles of What If, an inquiry approach to teaching maths. I hope that through this video you'll be able to understand how the approach works and the rationale behind it. I believe that mathematics is a collection of extended collaborative games of what if played by mathematicians who set up rules, axioms, and then explore the consequences, theorems of following those rules. What if I had an addition that totaled 5,555? Why not create your own one? I've come up with 2,383 add 3,172. What's yours? What if we scored a point for every digit that we used only once in the add-ins? I can see that I have used the digit 2 twice and the digit 3 times. They don't score me any points. However, I have used the digits 1, 7, and 8 only once. They each score me a point. As such, this calculation scores 3 points. How much would your calculation score? As mathematicians, we have created a set of rules that our additions need to add to 5,555, and that each digit used only once in the add-ins scores a point. We are now ready to explore the consequences of those rules. We are not just interested in the most number of points, but all the possible points that could be scored. What strategies do we need to use? What mathematical concepts will we need to employ? Are some results more likely than others? It's only through the creation of further data and sharing it, studying it, and discussing and arguing about it that we will understand. We've invented a new mathematical situation, and we are now seeking to understand it collaboratively. In the Isles of What If, we use the analogy that a set of rules created is an uninhabited island waiting to be explored. When we first reach this island, we are grasping the initial rules and focusing on an individual case. And this is the first of 3 phases of the inquiry. This is called the landing spot. If we imagine the whole island as containing all the understandings possible within a set of what-if questions, we've only scratched the surface at the moment. We've got one example. There are a lot of unknowns still. We've just landed. We have a lot to uncover and explore. There are lots of directions we could go in individually, but at the moment we are together in one single spot, the spot that represents the initial case that we have looked at. We don't just give the children complete freedom from the start. We ensure that they are equipped with the understandings and tools necessary to delve deeper into the problem. It's about everyone understanding the problem posed in an accessible way, and we can gradually change or remove or introduce new constraints and expand our search. And in this search, we are trying to find treasure. The treasure of maths is discoveries, patterns. We seek to make conjectures, validate and understand them, and collectively agree on their truth. It is through this that we unlock the riches that maths provides. We don't know yet what kind of treasure awaits us on the island of adding up to 5,555, where we score a point for each unique digit. It is only through the creation, sharing and exploration of the data that we will find it. In doing this, we will use a set of repeatable skills that are used across any inquiry to aid us in our discovery of treasure. They aren't used in a specific order. They might be different with each island. The first set I will introduce are the explore skills, and they are perhaps the most fundamental to the Isles of What If. We have focused on one case that scores 3 points. We now need to shift our focus to other possibilities. Rather than just staying with 3 points, let's move deeper into the island, reorient and focus onto other points. On this island with this problem, we can imagine the island as having different areas for different points values. We will come back to the departing skill later. In reorienting, the children might go off in their own direction to uncover more about the island. This is the second phase of the inquiry, the island phase. We are going beyond the initial landing spot and creating new examples and data and making sense of them. If we think about the island as each spot containing every possible calculation that they could do to reach 5,555, they are trying to go further into the island to locate treasure, the patterns that describes those calculations. That doesn't mean they have to have visited every single spot to be successful. However, they're trying to understand as many of those particular spots as possible. Here, we've created two more examples. We've got one that scores 6 points, and we've got one that scores 2 points. When they're creating data and examples, they will use the search skills. Roaming might be needed initially, where they just randomly create examples, and this might be used to get a feel for what is going on. Combing, in this case, might be adjusting the digits that they have used ever so slightly to create more examples. So they've created one calculation and just using a minor shift, creating a new one. Seeking is about looking for something specific. So they might seek if they were trying to create examples with the purpose of specifically creating a point score of 4. We're not just creating data, but seeking to understand it. For example, in trying to score 1 point, we might find lots of ways that don't work initially. The children might have to persevere and use their problem-solving skills to consider how a score of 1 is possible. In doing this, when reaching a score of 1, they might conjecture that to score 1, both numbers must be in the 2000s. In the Isles of What If, making a conjecture is akin to determining an X marks the spot location. We believe treasure to be there, but we have neither investigated it or unlocked the chest containing it yet. Further work is needed for the riches to be revealed. We name conjectures after the person or people that make them, to give them a sense of ownership and empower them. It's a sign of respect that we collectively investigate their idea. Here we've got Rupert's added pairs of 2000 conjecture. These X marks the spot will happen through the discover skills. Noticing is about spotting something in the existing data. It's looking at the data we already have and identifying something. Conjecturing is about making a prediction about what unexplored data will look like. So it's trying to predict what data that we haven't even created yet, or a partial set of data, looks like. Adapt is an important skill about making changes to a conjecture, perhaps after a conjecture has been proven false, to make a new conjecture and a new location of treasure. So we have the conjecture that a point score of 1 is only possible when both add-ins are in the 2000s. This is our X marks the spot on our island. Now we need to investigate it. Inspect means to look at the data already created to see if there are any counterexamples already. A counterexample is something that proves something false. So if we found an example where we managed the score of 1 and both add-ins weren't in the 2000s, then that would be a counterexample. Dig means to create new examples to test the validity of a conjecture. We're trying to create, perhaps, a counterexample to disprove a conjecture, or more examples that follow the pattern and validate the conjecture. Expand means to dig by thinking about peculiar examples that aren't necessarily the most obvious ones, that test the limits of a conjecture. We'll look at an example of that now. Here, I could expand and dig by creating a new example using decimals. It is indeed true that with integers, add-ins in the 2000s are necessary for a score of 1 point. However, by using decimals, we have found a counterexample and proved a conjecture false. Now, in doing so, in proving the conjecture false, we have unlocked the treasure. It is not the case that only conjectures proven true are treasure. In proving the conjecture false, we now understand more about the island, the problem we are looking at. And as such, we have revealed treasure. We don't want children to make conjectures that are just safe. We want them to be able to take risks and make conjectures that they are uncertain about, but believe to be true, that warrant mathematical activity, that promote mathematical thinking. Our conjecture did this, and as such, it is valued as resulting in treasure, even though it was proven false. And from conjectures, we might have all kinds of different treasure: wondrous treasure, strange treasure, beautiful treasure. We want children to reflect and be in awe of what they have created and their ideas. This is part of being a mathematician. As we uncover more data, and you might choose to have a go at this problem yourself before carrying on with the video, we reveal more and more of the island. This is because we now have more and more examples of data, and we understand the problem more and more. Some areas and scores may be trickier to reach than others, up mountains or the other side of rivers. They might take significant effort to reach, but we are explorers as mathematicians, and we will try and reach there. In creating the data, we will often find ourselves needing to organize it in various ways. Here we have the Organise skills of arranging, comparing, and classifying to promote this. Let's imagine that we have explored much of the island with the problem of adding to 5,555. We've created lots of data, and I've organized it to show an example of all the scores that I have managed to create. We might notice that we've been unable to make certain values, and this leads us down to new avenues. We might have to think about how we can change our approach to achieve these. For example, with a score of 7, we might realize or try the approach of using a 4-digit number and a 3-digit number. This might help us to discover more treasure. The conjecture might follow, Loris's 3 and 4 digits conjecture, that to score 7 points, we must use 4 digits, a 4-digit number, and a 3-digit number. Once again, this is treasure awaiting us that needs to be unlocked. Whilst, as a community, we are uncertain of its validity, the treasure chest remains locked. This leads us to the arguing skills. To unlock treasure, we need to persuade, show, and prove our ideas. At a primary school level, the burden of proof, I believe, is not necessarily some sort of elaborate set of logical steps. Instead, it is simply that when the class community have been convinced that something is true or false, then we are convinced. You as a teacher might remain more skeptical than others. However, you are not the answer key. You are not there to say whether or not a conjecture is true or false. It is up to the class community to decide. If the class had gone away believing Rupert's conjecture around a score of 1 to be true at the end of the lesson, they will not have reached the truth. But I think that's okay. It is more powerful for the community to be the authority on validating ideas than for the teacher to turn around and say, actually, you are all wrong. Otherwise, what was the purpose of their efforts? We might highlight specific examples where there is particularly interesting cases or learning to happen, but generally, we're not there to tell them whether or not a conjecture is true or false. Now, we've explored much of the island now, but we've been unable to score values of 9 or 10. It would be reasonable to believe it is impossible. Using our arguing skills, our answer has only got 4 digits. This means that in our addition, we only have 8 digits to play with across 2 add-ins when we're using integers. What if we used decimals? An Isles of What If approach naturally leads to us making connections, bringing in more maths, and increasing our challenge in seeking our goals. Maybe you want to have a go and seeing if you can create 9 or 10 points using decimals. I'm going to spoil it now somewhat for you, but in fact, a score of 9 or 10 isn't possible using decimals. We've explored much of the island and uncovered so much. It might feel like we have completed our task. However, I don't want children to ever feel that maths is complete. There are always new avenues of exploration. We just have to be creative. I want children and adults to see maths as this ever-growing subject, full of new inventions and the possibilities to be creative. What if I said that a score of 9 was possible? What if I said that it didn't even require decimals? Would that be creative? And this is an example of where I might choose to share an individual case with the children, because it helps to shape their viewpoints of maths. What if we used more than 2 add-ins? We want children to constantly ask what if, to explore new ideas and avenues, to test the boundaries of what is possible, to be willing to go where no one has ever thought of. In fact, we can score 9 points by using 3 add-ins. I've not found a way to score 10 points, but who knows what kind of ideas you can come up with. Maybe you can go somewhere where I haven't been and score 10 points using your own idea. And in going somewhere that no one has gone before leads us back to the departing skill in Explore. This is the final skill we will look at, but perhaps the most important part of the Isles of What If. We don't want the Isles of What If to be seen as this fixed landmass, but instead an ever-growing world full of possibilities. The Depart skill is about changing the what if rules to create a whole new island to go even further. For example, what if each digit had to be greater than the preceding one? What if we use subtraction? What if each add-in had to be a different length? These what if questions would be whole new islands in themselves. They're related to the previous island, but they are new avenues of exploration and a part of phase 3 of the inquiry, the Archipelago Phase. We want children to see maths as a creative subject that is always growing. We want them to see themselves as inventors of maths. We want them to be able to be the world's greatest experts in the avenue that they have chosen to go down. That's a very powerful thing to say, but it is possible when they are not just repeating maths, but creating it. When we do these things, we are in the mathematical Isles of What If. If you want to find out more or look through the ever-growing collection of lessons that use the approach, go to islesofwhatif.com. I can also be found on Twitter, and I'd love to hear from you. Thank you for watching.